Hello, class. We're looking at solving linear systems by graphing today. So this is an introduction to linear systems. So what is a system of linear equations? So a system of linear equations is two or more linear equations with the same variables. Let's see if I can squeeze the word variables in here. Not quite. We'll adjust our camera a tiny bit. So two or more linear equations with the same variables. So when we think linear equations, I want you to think y equals mx plus b. That's what we mean. We mean linear because if we made it equal to y and graphed it, it would be a straight line. So a solution to a system of linear equations satisfies all equations in the system. So let's take a look at what that means. So we're going to do that for this first little part here. It says tell whether the ordered pair is a solution to the linear system. So what I've got is they've given me an answer, that negative 10 comma negative 8, that's an xy. And I want to know, is that the right xy that works for this whole system? Is that the xy that is a solution to the first one and the second one? And so what I need to do is I need to check it in both equations. This is an answer check. So first, I'm going to check the first equation. And the way I'm going to check that is when it says 2x, well, that means 2 times x. My x is supposed to be negative 10. So I'm checking, should x really be negative 10? Does this work? So I'm going to write 2 times negative 10 minus 5 times, instead of y, I want to have negative 8. And does that actually equal 20? That's what I'm checking. Does this really work? Is it equal? So a positive times a negative is going to be a negative 20. Here I have a minus, but I'm also doing 5 times a negative 8. So like I'm going to have a minus from this and a negative from this. So I know it's going to be plus. Negative times negative is positive, or minus negative in a row is positive. 5 times 8 is 40. So still checking. If I have a negative 20 plus 40, does that equal 20? And yes, because I could either kind of turn this around and say, well, this is 40 minus 20, or I could say different sign, subtract sign of the bigger one, but we get 20 is equal to 20. So let's check our second one. Negative x plus 2y equals negative 6. So now we're checking our second equation. You don't have to write that part. It's just me kind of showing you, explaining what we're doing with words. So if it says a negative x and x is already a negative 10, then when I say negative x, I'm really taking the opposite sign, aren't I? So this is going to be a positive 10 plus 2 times, let's see, y is negative 8. Does that equal negative 6? So 10 plus negative 16 equals negative 6, and this one's going to be true as well. So because it's a solution to the first equation and the second one, it is a solution to the system. So we're going to write yes. So now let's try the second one. It's negative 7, 4. That's my xy. So 2 times the x is a negative 7 plus the y is a 4. Does that equal negative 10? Negative 14 plus 4. This one seems to work also. All right, so then let's check the second equation. This one says y equals negative x plus 4. So my y is 4. Negative x, well, x is already a negative 7. So again, and if it says negative x, I'm going to have to make it a positive 7 plus 11. This one's not going to work at all, is it? 4 does not equal 18. And since it does not equal 18, this is not a solution to the system. It's a solution to the first equation, but not the second one. So it is not a solution to the entire system. That does not mean that there isn't a solution. It just means that negative 7, 4 is not the one. So we would have to keep working if we wanted to solve that. So let's take a look at this first solve by graphing. So I'm going to go ahead and go through my graphing steps. I'm going to use kind of a marker here to help me graph so you can see it better. So if my y-intercept is 3 and my slope is 1 over 1, remember you're starting at the 0, 3. So I'm going to give us some little solving directions here. okay? And then a slope of 1 over 1 means I'm going to go up and right. And I've got to make a bunch of points on this line. So let's see, here's 0, 3. And then if I'm doing a slope of up 1 over 1, so let's see, up 1, 1 to the right. I'm making all these points. So every point that I make on this line is a solution. Those are all the ordered pairs that work in this line. And really, there's points in between. It's just they're not integer points. So like between this one and this one, I would have like an x of 1.5 and a y of 3.5. And that doesn't mean that that's not a solution. It's just not the dots I'm making. It would be impossible to make all of them. So there's my first line. And remember, again, we want to think about how every point on that line is a solution. Now I'm going to graph my second one. I'm going to pick, I don't know, I guess this ugly brown color. It's not ugly. So we're going to start this one at 0, 2. And this one has a slope of 1/2. So 1/2 means we're going up and right again. They're both positive. So we're starting at 0, 2, and I'm going up 1 over 2. All right, so let's go back the other way. So if all of my blue points are solutions to the blue line, and all of the brown points are solutions to the brown line, it looks like right here is a solution to both because that's where they intersect. So the important idea that we want to develop in this section is that wherever our lines intersect is going to be that solution. That's going to be the ordered pair that satisfies both equations. And so if I think about where that is on my x, let's see, this is my x-axis, right? So here's 0, -1, -2 for my x. And then my y value, here's my y-axis, right? My y value shows it's up 1. So be really careful because I know when we do slopes, we're doing a rise over a run, which is kind of like a y over an x. But when we do ordered pairs, it's x and then y. Ordered pairs are alphabetical order. I could show this works in both of my equations. I'm going to just do one answer check, and then after that, we're not going to worry about it. So if my first equation was y equals x plus 3, and I'd put the 1 in for y and the -2 in for x, and that's true. 1 equals 1. Okay, so now we're going to check our second equation. Y equals 1/2 x plus 2. So the y would be the 1/2 times -2 plus 2. So half of 2 would just be 1. Positive times negative would be a -1. And -1 plus 2 is 1 again. So it satisfies both equations in the system. So we've proved it works over here with our check. And we have this cool visual representation of the lines crossing, and that's our solution. So our solution here is -2, -1. So we've solved it by graphing. So let's go ahead and take a look at one more in the back, and then there's one for you to try on your own. So on the back, I have a system, and this one's not y equals mx plus b. So I want to graph things that are y equals mx plus b. If it's not y equals mx plus b, I have to do a little bit of work. So this one has x minus y equals 5. So in order to make it look like this, I'm going to have to move my x to the other side by subtracting. So now I have -y equals -x plus 5. And then I need to take, it's really like a -1 in front of this y. And I need to go through and divide everything by that -1 so that I'm working with a positive y instead. So now I have y, negative divided by negative here is a positive x. 5 divided by a -1 is a -5 or a -5. I could either write plus -5 or -5. Those are both fine. So we're going to start at 0, -5. And remember, there's always that imaginary 1 in front of the x, so my slope is a 1 over 1 again. I'm going to go up and right. So let's go ahead and do this first graph. And I'm going to do this one in blue again. So let's find -5 and up 1 over 1. And I really did count down 5 from the middle. I've just been graphing on these grids for a really long time, so I can kind of just look at them and see. I'm going up 1 over 1. All right, connect my line. Now I'm going to have to do a little bit of work for the second one because the second one's not y equals mx plus b either. So let's go ahead and write that over here. We're obviously not going to have room for a check on this one, and that's fine. So y plus 3 equals negative 3 times x minus 2. So the first thing I notice is there should not be any parentheses. So I'm going to go ahead and distribute. Because if I'm looking at y equals mx plus b, I just have a slope times my x plus a y-intercept. So we'll go ahead and distribute. That'll give us a negative 3x. And then negative times negative is a positive. 3 times 2 is 6. And now to get y by itself, I'd have to subtract 3. 3 is just a constant, so when I subtract it on this side, I want to line it up underneath the 6, which is another constant. So now I have y equals negative 3x plus 3. So I have a slope and a y-intercept again. So this time we're going to start at 0, 3. And our slope is going to be negative 3 over 1. That means we're going to go down and right. We're still moving right because the 1 is positive. So let's go ahead and graph that second one. So starting it at 0, 3. And down 3 over 1, down 3 over 1. Look, they cross right away. So once they cross, we can really quit graphing that line. And it looks like this time my x value is what, 2? And my y value is down 1, 2, 3. So 2, negative 3. So you still have one problem to try on your own. Notice yours are in y equals mx plus b form. That'll make it easier. And you could check out those completed notes to make sure you got the right answer on that. Make sure you bring your questions to class.